Have you ever pondered about the future of technology? What if there's a machine that could solve complex problems in seconds, problems that today's computers would take thousands of years to solve? Now, let's take a journey into the realm of possibilities. Our classical computers, as powerful as they are, have their limitations. They work with bits, the smallest unit of data, represented as either zeros or ones. But imagine a computer that doesn't just work with zeros and ones. Enter quantum computing, a revolutionary technology that promises to redefine the boundaries of computation. Quantum computers don't use traditional bits, instead they use quantum bits, or qubits. Here's the twist: a qubit can be a 0, a 1, or both at the same time. This strange and fascinating concept unlocks the potential for calculations far beyond what we can currently achieve. Now you might be wondering, how does this strange concept of quantum computing work? To understand quantum computing, we need to delve into the world of quantum mechanics. Quantum mechanics, in the simplest terms, is the study of particles at the quantum level. It operates on principles that seem strange and counterintuitive, but are nonetheless fascinating. For instance, in our everyday experiences, an object can exist in one state at a time. An apple is either red or green, but not both. However, in the quantum world, this isn't the case. A quantum particle can exist in multiple states simultaneously, a concept known as superposition. Imagine a coin that's spinning. It's neither heads nor tails, but both until it lands. That's like superposition, but for quantum particles. Only when we measure or observe the particle, it collapses into one state. It's a bit like Schrödinger's cat, both alive and dead until you open the box. Now, let's talk about entanglement, another quantum phenomenon. Imagine two particles that have interacted with each other. Once entangled, the state of one particle will instantly affect the state of the other, no matter how far apart they are. It's as if the universe has a cosmic speed dial connecting these particles. This isn't just theoretical, scientists have observed this happening. How does this all tie into quantum computing? Traditional computers use bits as their littlest unit of information, which can be either a 0 or a 1. Interestingly, quantum PCs use quantum bits or qubits that, due to superposition, can be in a state of 0, 1, or both at the same time. Furthermore, entanglement allows qubits that are entangled to work together, providing a vast increase in processing power. It's like having a team of workers who know exactly what the others are doing, instantaneously, no matter how far apart they are. So, we've seen how quantum computing works, but what makes it so powerful? Well, imagine a problem that would take a traditional computer millions of years to solve. A quantum computer, utilizing the principles of superposition and entanglement, could potentially solve that same problem in mere seconds. The potential is truly mind-boggling. Imagine a maze with 1,000,000 routes. A classical computer would check each route one by one, but a quantum computer would check all routes at once. This is the power of quantum computing. A power that is not just theoretical, but also practical. Where traditional computers use bits, quantum computers use quantum bits, also known as qubits. Unlike a bit that can be either a 0 or a 1, a qubit can be both simultaneously because of a property called superposition. This permits quantum PCs to play out different estimations at the same time, giving them the possibility to tackle complex issues and process vast amounts of data at incredible speed. But the power of quantum computing doesn't stop there. Another property called entanglement means that the state of one qubit can depend on the state of another, no matter how far apart they are. This could lead to new ways of processing information, where data can be transferred instantly, regardless of distance. Now imagine the potential applications of such a technology. In medicine, it could help us understand how molecules interact, leading to new drugs and treatments. For cryptography, it holds the potential to break current encryption methods, but also to create new, unbreakable ones. In the field of artificial intelligence, quantum computing could accelerate machine learning, making AI even smarter and more capable. It could also revolutionize industries that rely on complex calculations. For example, in finance, it could optimize portfolios and manage risks more effectively. In logistics, it could find the most efficient routes and schedules. And in climate science, it could model the Earth's climate with unprecedented accuracy, helping us to understand and perhaps mitigate the effects of climate change. Quantum computing holds the promise of a major technological revolution, but how close are we to seeing this revolution? The reality is, we're still in the early stages of quantum computing. It's like we're at the dawn of a new era, much like when the first computers were built. But let's take a look at where we are today. A number of major corporations and institutions are making significant strides in quantum computing. Companies like Google, IBM, and Microsoft, as well as research institutions like MIT and Stanford, are leading the charge in this new frontier of computing. They're pushing the boundaries of what we know and what we can do with quantum computing. Now, as with any new technology, there are challenges to overcome. For one, there's the issue of qubit stability. You see, qubits are the basic units of quantum information, and they're incredibly sensitive. Any kind of interference can cause them to lose their quantum state, which is a phenomenon known as decoherence. This is one of the biggest hurdles in quantum computing today. Then there's the issue of error correction. Because of their sensitive nature, qubits are prone to errors. And unlike in classical computing, where an error can be corrected by simply flipping a bit, in quantum computing, error correction is far more complex. It involves identifying and correcting errors without disturbing the delicate quantum state of the qubits. Despite these challenges, the potential of quantum computing is enormous. It could revolutionize fields like cryptography, material science, and even medicine by enabling us to solve complex problems that are beyond the reach of even the most powerful classical computers. So while the quantum future might not be here just yet, there's no denying the potential it holds. Quantum computing could be the key to unlocking solutions to some of the world's most complex problems.